And now we are recording. Yes, it seems so. And then, sorry, the screen keeps flickering a little bit because I'm changing my contents on the other screen, but hopefully that doesn't bother you. Okay, so I think we can now get moving. So hello to everybody and welcome to this One Click LCA Building LCA training session organized as a part of the Saint-Gobain Architecture Student Contest. So my name is Maija Kymäläinen and I am working at One Click LCA as a sustainability consultant, and I am also organizing these kinds of trainings every now and then. So today, I am here on behalf of One Click LCA to get you acquainted with the topics of life cycle assessment, theory, and practices. Some training rules for before we start. So keep your microphones muted. I'm not sure if you're even able to open them, but in case you are, don't do it. So otherwise, we will be drowned in conversation. You can ask your questions via the Teams Q&A function. So the chat function, unfortunately, is not enabled as this is a town hall meeting. And here we are using the Q&A function. So leave your messages there if you have something related to the contents. I will be answering these questions during the Q&A session. So at the end of this session, we will have some time for questions. At the moment, there are no moderators for this session, so if there are any questions left unanswered, they will be addressed in the One Click LCA community. I have here attached the link. I will return to the community in a few slides. These recordings and slides are made available tomorrow on the academy.oneclicklca.com page. So before we go into the actual topic, I would like to give the mic to Timo from Saint-Gobain. So he will say a few welcoming words and introduce the contest. So Timo, please, the floor is yours.
Thank you, Maija. Can you hear me okay?
Yes.
Yes, perfect. So welcome everybody that is present to this first session on how to use the One Click LCA tool to carry out the life cycle assessment of your buildings. Just to give some context, but you already have read the contest task. The idea is to use the software on the new building project that is going to be placed in a city near Lyon in France, which is a contest task for next year. And as you probably have within the contest task, and just in general as a future professional architect or engineer, you'll see that life cycle assessments are becoming more and more important in the near future. There are a lot of legislation, not only in France, but also in other parts of the world like Colombia, the US, many countries in Europe, where take into account how materials are going to impact the decarbonization of the building sector is becoming a more key of a subject. So the logic and intention of the contest task is for you to be more aware and have some experience on this topic within this activity of this contest within Saint-Gobain. So you can complement that with what you're doing with the universities on how to best reduce embodied carbon of material. So that's a little bit of why we want to do this and why we think it should be part of the knowledge you start to develop as a future profession. Again, as I mentioned, within the contest, the requirement to do a life cycle assessment is only aimed for the new building, where you will have obviously more opportunities to provide different solutions and materials for your design and be able to test. The idea is for you to play with all of this data and information that Maya is going to be sharing with you between today and Thursday. So that as you build your design for this contest, as you can support, you can leverage this information to make the case of why your building takes into account a holistic approach to sustainability. Just to finish that, if there's additional questions you may have had related to the contest task, remember that there's a frequently asked questions in the Architecture in the Contest site where you can write your question. I will share that with the local partners in both cities in Milan and the Gran Santeria for them to give us clarity if it's something that is not already included in the contest task. And with that, as Maya mentioned, this session and third session will be recorded for other people to also look at, throughout the next couple of months to make sure that, you really take advantage of all the aspects of the tool in terms of analyzing your project, and that you can also leverage and use this information for other projects that you may be doing within your school curriculum. With that, again, hope all the best in the next couple of months while you're doing your project within your teams, and the best of luck also when the country contest happens in the next Q1 of 2025. So looking forward to seeing what you have done and share with you during the contest event next year. And I will leave it back to you, Maya. Thanks for the space for the introduction.
Thank you. Thank you for the introduction to the contest, and also giving a short background on what the LCA part is going to be doing there. So if I continue from there, also from our side, why would we have a building LCA training course? Well, this course is designed for you as architect students to give an overview on life cycle assessment. So some background, some theory onto what is life cycle assessment and what you can do with it, and why you should be doing it as well. And there's also then the practical guidance on how to actually deliver an assessment. So what you will learn during this training is you will learn to understand the impact of the construction sector on climate change, the need for building sustainability, and the regulations also driving the building assessments. And you will also learn about the core concepts of LCA, so including building lifecycle stages, the environmental impact assessment, and also the data required to perform LCA with hands-on software training. And you will also learn how to use OneClick LCA software, and also not in this session, but on Thursday's session, you will also learn to use Carbon Designer 3D, which is our early stage design tool. So what is included here is we're hosting 2 separate training sessions on the topics of climate change, construction industry materials, practical life cycle assessment, and optimization as well. So the next session will be held on Thursday, same time as this one now. So what we offer you is a free license to our life cycle assessment software. We give you this training, and also in the academy you will find additional materials that will be available for you for the entire duration of the course. So the course and the contents will be closed on the last day of June next year. These sessions will be recorded, and the recordings will be uploaded to the course site the next working day. And if you have not registered yet to the course, you can do it also later. It's up to you, but I do urge you to check it out. And everything is available in the academy. So this is, I can show it to you here. So we have the link here. In the academy, you will find introduction to the course. So here you will find the contents of the sessions. So this is session 1, and this is session 2, the rules of the training, also links to the community page, and also to the Saint-Gobain Architecture Student Contest YouTube channel, and some practical information as well. You will find information on the software and also the support provided. So we have this OneClick LCA Help Center here, and also a short intro into how to access the OneClick LCA software, but this is something that we will also go through in this session. So whenever you have trouble, just return to the recording and you can find your answer there, hopefully. And we also offer you the exam, which you can find here on the left side. So here you will find the course overview, accessing the OneClick LCA software, links to the live sessions, and also all these optional self-study materials that you can go through. that will give you more information, and also then the exam here. But yes, so check that out and make yourself acquainted with all the materials there, and this will help you along in your journey to life cycle assessments. Yeah, so as I mentioned, the exam, and there's also the certificate of completion. So if you pass with over 90% rate, you will get a certificate with acknowledging this course and your proficiency in basic LCA. And the exam will be opened after a Thursday's session. So then from there on, you can take it whenever you want, whenever you wish, how many times you want, and all the way until the course ends at the end of next June. And then about the community. So we have a OneClick LCA community that you can enter through the link here, for example. And here you can ask questions. So I will be checking it every now and then, and also my colleagues will be there answering your questions related to LCA or the software. And you can also check if your fellow students are needing help and answer their questions maybe, and also check if there's any announcements. And there's also a lot of like news and exciting events that we are posting there continuously. So you can just go to these slides, click here, and you will be taken to straight to the community page where you can write your questions. So if we go then to today's session, so today we will have an introduction to building LCA and also the software training. So as I mentioned, we will go through the climate change and how it relates to construction industry. What is LCA and what are the building LCA stages, what kind of data there is. So we will take a look at EPDs, for example, legislation and standards, and then go through training to see how you can create your account and access the software, and then have a demo of the software as well. And then at the end, as mentioned, we will have time for a Q&A, and also the self-study assignment will be given out. This is something that you don't have to do, but it's just something that might promote your learning process. On Thursday's session, we will go through the building LCA process in early stage design. So how you can reduce emissions. We have some practical examples here, and we will showcase our early stage design tool, Carbon Designer 3D. That might be very, very helpful for you when you are designing that new building for your project. And also we will check out how you can optimize results then from the baseline. Now let's go to introduction. So of course, whenever we are talking about representing our company, we have to give a short introduction into what the company is. So I am from OneClick LCA, and what we do here is we power the makers of zero carbon future. So that is our mission. And this means that we provide the necessary tools and training to enable the change makers, such as everyone who is listening today, because you are the ones that are actually making the change in buildings. So we are the world leader in construction and manufacturing LCA softwares. So we provide tools to conduct LCAs for buildings, materials, also infrastructure, and also for your company portfolios. And we aim to have LCA made easy. So basically no PhD required. It doesn't hurt if you have one, but you don't really need it. So you don't basically need years of training to learn how to use it. So what you need is a basic understanding of the construction industry, of the materials, and then the software guides you forward. Here you can see some of our customers. So we aim to connect the entire industry. So engineers, architects, manufacturers, builders, investors to institutions. And to our customers, we provide a global platform for data and tools to make calculations in compliance to certification schemes and regulatory frameworks. So OneClick LCA is a global platform that supports over 60 different certifications and regulatory frameworks, and also includes the world's largest data bank of construction materials. And now that number is over 200,000 data sets. So that's a lot of data you can use. And you, with OneClick LCA, you can improve at every project phase. You can share data, connect data, all the way from strategic definitions to concept design, construction, and then final reporting. And we also provide building information and building energy model integrations for all the design stages. And here are some of our integrations shown here. And finally, OneClick LCA provides free training for everyone interested, reports, policy works, research articles on meaningful matters, and we are a team of experts that are ready to support you in your journey to decarbonization. But that was about OneClick LCA, so let's dive deeper into today's agenda and continue with the look into climate change and also the role of construction industry. So if we continue with this graph from the United Nations Environmental Programme emissions gap report, which shows the annual CO2 emissions in gigatons and the different scenarios with associated emissions. So currently we are somewhere at 57 gigatons of CO2 equivalent per year. And in the current policy scenario, we will have made basically no progress by 2030 on average. So this scenario entails means that have been implemented or agreed to be implemented at a global scale. So yes, so here we are at 57, and here we have all the different scenarios and their respective emission gaps. So as we know, the 21st Conference of the Parties, 196 states agreed on the objective of limiting global warming to well below 2 degrees and if possible to 1.5 degrees. So the countries submit these nationally determined contributions or NDCs that represent the climate action plans of countries covering their efforts to reduce national emissions and adapt to impacts of climate change. So the unconditional contributions here are ones that are implemented based on the country's own resources and capabilities. And then the conditional contributions are the ones which countries would undertake if international means of support are provided or other conditions are met. And you can see here that despite these joint efforts, which would take us to this level, none of these scenarios are on track with recommendations from the scientific community, but there are these very big gaps that are remaining for us to reach 2 degrees or 1.5. So to get on track for limiting global warming to below 1.5 degrees, the global greenhouse gas emissions must be reduced by over 40% compared with the current policy projections. So this means basically cutting almost 9% per year. And if the unconditional NDCs are fully implemented, the gap is 22 gigatons annually. And if the conditional NDCs are also implemented, the gap is somewhere 19 gigatons. So this is quite a gap that we are still needing to work with. And where does the construction industry come in? So buildings are responsible for nearly 40% of global carbon emissions. So about 3/4 originate from operational emissions. So that is electricity, heating, and emissions originating from those. And the remaining 1/4 is from materials and construction activities. And within these materials, the main impacts come only from 4 main materials. So that is cement and concrete, and then steel, plastics, and aluminum. So very big emitters there. And it's been projected that until 2060, the global population grows by nearly 3 billion people, and basically all of it is expected to happen in the cities. So that means a huge amount of floor area is needed to build. And thus it has been also predicted that cities will actually double in the next 40 years. And this will create up to 200 gigatons of embodied carbon that comes from construction materials only. And this translates to global greenhouse gas emissions of up to 3 years globally. materials only. And this is also can be related to building a New York City every month until the year 2060. And for this reason, the World Green Building Council has stated that we need to be cutting embodied carbon now. And it follows that all construction needs to be operationally carbon neutral and create at least 40% less embodied carbon by 2030. And it's obvious that the construction industry needs to act very fast. And just as a clarification, when we talk about embodied carbon, we mean all the greenhouse gas emissions embedded in the materials. So these originate from the excavation, the processing, the manufacturing, transportation, the use, and the end-of-life processes of materials. So basically everything except the operational energy use and the water use of the building. And if we look into a bit deeper into the emissions related to buildings and see where the climate impacts mostly come from. So this is an example building from Finland. So it's a typical Finnish apartment building with 4 floors and a cellar and a floor area of about 300 square meters. And it has been assessed with the Finnish assessment methodology that is compliant with the European standard and calculated over 50 years. And the values used here are predominantly statistical averages from data that is gathered from different projects that has been assessed with One Click LCA. But you can see here that the biggest impacts are embodied, so they are related to materials. So approximately 44% of the building's life cycle emissions come from the A1 to A3. So this is the product phase. So these are basically the extraction of raw materials and the actual production of the product. And then the next bigger emitter with a bit less than 40% is the B6. So this is the operational carbon from energy. So basically all the energy that goes into the building during this calculation period of 50 years. And then we have all these different parts. So these are material replacements. So again, material impacts. These are the construction site activities, which are again counted to material impacts, the transport of materials, and then also the end of life, which also is accounted, which is assigned to the materials. So this is what it would look like in Finland, at least. And if we then look at this issue on an annual basis, we see that there's an important emission peak at year 0, so when the building is being built. The peak entails all the materials manufacturing impacts as the high blue column here, and then the transportation to construction site, and then the construction site activities. So these all take place before the building is built. So these small pink ones here are material replacements that take place during the service life. That is here calculated as 60 years. And then the operational emissions are divided evenly throughout the life cycle of the building until the end of life. So these are represented by the green ones. But if we look at this from another point of view, so we know that the energy sector is decarbonizing quite rapidly. So there's a lot of different means that have been taken into action here. So we have the electricity grid is decarbonizing due to wind, solar, things like that. The fossil energy is going down. So the emissions from the energy are actually going down. So within service life of 60 years, the situation might look like this. So we have the energy, the replacements actually are going down quite efficiently. However, we are building the building today, so this part here doesn't go anywhere, so it stays. And this is the part that needs most attention here. So as said, materials will become the dominant source of CO2 emissions from buildings in the future. And as we saw, the operational emissions from energy, they still form about 40, 50, maybe even 60% of the life cycle emissions. But this share may already be as small as 10% in passive houses, for example. The average material emissions are exceeding the operational ones already in some countries. So, such as we saw in Finland, it was something like 40% of the whole life cycle emissions. In Sweden and Norway, they might be very small because the energy grid is very green, basically. So there's no fossil energy used. So in these places, the embodied emissions are already exceeding the operational ones, and this is happening also in other places in the world. So this operational part is going smaller, and the material derived impacts are growing in proportion. So the embodied carbon, or the material embedded carbon, is simply the next level in energy efficiency and decarbonization. So as we are moving towards this holistic carbon management, we need to be taking these things into account. So we started in the 70s by improving energy efficiency of buildings, and this is a continuous effort. Energy grids are decarbonizing, but then we need to address also the materials to be able to say that we are doing good choices in a life cycle basis. And although the situation may seem dire, so we are getting ourselves deeper into global warming, but there's also changes happening. So there's an ever increasing demand for carbon neutrality in the market, and the need to make changes also in the building sector is getting ever clearer. So in that sense, we are in a lucky situation. And you are also, because you are learning about LCA, and this is something that is becoming the norm and therefore required by businesses, regulation, certifications. So being less bad no longer cuts in the market. So you need to actually show that you are doing good choices. And for example, these kind of certification schemes are one key. So you might pursue certificates and by that show that you are acting better. But there's also a lot of regulations that drive the life cycle impacts and the carbon footprint of construction materials. So that was our look into climate change and construction. So now we move on to talk about what exactly is life cycle assessment and how you can begin implementing it in your projects. So life cycle assessment is a holistic approach to the environmental impacts of a project. So what it does, it avoids shifting of burdens from one life cycle stage to another by addressing all stages, and provides also results in a way that makes it easier to implement these desired changes to products, processes, and services. So this ensures that means are also timely, so they take place early in the design process. So how the assessment works, very much simplified, is that once we've set the scope and boundaries to our assessment and assumptions, then we get material information, convert the inventory data into a set of potential environmental impacts, such as global warming potential or, for example, eutrophication. So when we are talking about greenhouse gases, embodied carbon, carbon footprint, that means that we would get information about the different greenhouse gases, and then we would use a factor derived from the IPCC characterization model, which is applied then to convert the life cycle inventory results to the common unit of kilograms of CO2 equivalent. And this is describes the global warming potential in the impact category of climate change. The process can be implemented for materials, so processes only, for different life cycle stages, or for the whole life cycle of the building. And the LCA outputs are environmental indicators. So they're called impact category indicators, and each of them has an effect on certain impact category. And what they do is they describe environmental impacts. So the impacts are expressed as quantities of matter that has the potential to cause such impacts. So they do not actually represent the actual harm, which is then the final impact. So for example, global warming potential represents the kilograms of CO2 equivalent released, and it has the potential to affect global warming, but the final impact might be the acceleration of polar melt, for example. Here are some common impact category indicators. So we already mentioned global warming potential, GWP. So this means how much a product contributes to climate change. So, and then when LCA concerns only this impact category, it is also called carbon footprint. There are others, such as acidification potential, eutrophication potential, ozone depletion potential, and photochemical ozone creation potential, for example. And these indicators are usually named potential because they have the potential to cause impacts. And the impact categories, on the other hand, are, for example, for global warming potential, the impact category is climate change, and for acidification potential, it is acidification of environment. But there are also others, such as depletion of fossil resources, which describes how much fossil resources are withdrawn from the environment. And there are a lot of these, but you can find more, for example, from our academic courses. If we then proceed to see how these impacts are calculated throughout the whole life cycle of a building, we must first get to grips with the standardized approach to life cycle assessment. So this infograph here explains the EN 15978 standard, or the Sustainability of Construction Works standard. And these describe the life cycle modules and stages. So what we have here is a life cycle of a building. These different terms here describe modules, and then they make up together stages. So A1 to A3 is called the product stage, and it includes raw material extraction, the transport of that raw material to manufacturing site, and then the actual processing to create a product or the manufacturing. And when we have a ready-made product, we are at the factory gate, and from the gate, we have transport to site. So A4 module takes us to the construction site, which is then has this A5 or the construction site activities. So basically everything that goes into building a building, installation, assembly, so on. When the building is finished, we enter the use stage, which includes modules B1 to B7. And these are separated because these are operational and all the others here are embodied. So like I mentioned, related to materials. So B1 to B5 holds the use stage impacts from use, maintenance, repair, replacement, and refurbishment. And then these operational B6 and B7 are the operational energy use and the operational water use. So everything that goes into the building during its lifetime. And when the building reaches end of life, it is taken apart. It enters the end of life stage. So here we have C1, which is the deconstruction and demolition, the transport of that waste into processing or disposal. C3 holds the processing of waste into new materials, and C4 has the final disposal into landfill. So this is called the whole life cycle of a building, but we can also include something else. We can include benefits and loads that are beyond our system boundary, and this is module D. So this is something that is always declared separately, and it can be positive effects or it can be negative effects. So it's called benefits and loads beyond the system boundary. So this is the net impacts and benefits from reuse, recovery, or the recycling potentials expressed as net impacts. It can be the recycled materials, or it can be energy, for example, from wood combustion. So this is a more common representation of a building's life cycle. So these are the stages according to the EN 15978. So you can see the same stages and modules as in the previous slide. And you can also see how the module D is here cut off from the rest of the building life cycle with the dashed line. So this highlights that it's a separate thing. We can do several kinds of assessments. So what the regulations currently only focus on is this small part of a building's life cycle, or the operational energy use. So this is something that has been dealt with, like energy performance requirements, for a long time already. But there are other kinds of assessment types. So this is something that considers only the initial materials impact. So this is a cradle to gate assessment. So this is something that can be seen with materials in some cases. If we include the transportation and construction impacts, we have a cradle to practical completion assessment, or we can also call this the upfront carbon assessment. And if we are considering the end of life as well, we have a cradle, the use phase and the end of life, we have a cradle to grave assessment. So this is a most typical approach for building LCA. And then if we bring in module D, we have a cradle to cradle approach. So this is where the circular economy comes in. So nowadays we are mostly aiming for these kind of cradle to cradle assessments. And also the material LCAs should now report module D for recycling benefits and loads as well. And if we are making an embodied carbon assessment, we just leave out the operational part as pictured here. So what is the best time to conduct an LCA assessment? So the answer is sooner the better, as the decarbonization potential actually halves after each project stage. So you can have the greatest impact here in strategy phase, and then when you have reached the as-built phase, there is practically not much you can do. So the sooner you start, the better. And this is also highlighted in this picture. So changing the project direction becomes increasingly difficult and costly when the project progresses. So this limits the decarbonization potential as well as the ability to influence specifications. So what you should do is concentrate on these early stage to make the big lines and then continue from that. Then let's go into data and EPDs. So if we start with the terms, what is an EPD? So for LCA, data is key and you need the data to be reliable. So what you would most often turn to is an EPD. So this stands for Environmental Product Declaration, and it is a document that holds basically the life cycle assessment for a material. So EPDs are externally verified descriptions of the environmental profile of any product or material over its lifetime. And this helps transparently communicate the product's environmental impact, usually provides a summary of cradle-to-grave emissions. And EPDs are standardized. So in Europe, they follow this EN 15804 standard with amendments. So we have the plus A1, which is becoming obsolete, but you can still find these kind of EPDs and use them. But now all the new EPDs that have been published until since 2022 in Europe, you have to align with the plus A2 amendment, which has some additional requirements. So why are EPDs useful? They are objective, so they are based on internationally accepted standards and validated LCA methods. They're credible and neutral, so EPDs are critically reviewed, approved, and maintained by independent third-party verifiers, and they do not make environmental preference claims. So even if you have an EPD, it doesn't say that your product is better than some other product. It just gives you valid information on what the environmental impacts are. They are open, so they are applicable to a wide range of products and services and can be easily accessed via the internet, for example. So they are public documents, so you can actually go to the internet and search for EPDs and you will find a lot of them. They are environmental impact oriented. So while having an EPD doesn't mean the product is necessarily good or bad for the environment, it does assess the potential environmental impacts, and having that information is something that we require when we are doing LCAs. And they are also instructive, so they give general information as well as explain terms, definitions, and LCA concepts, and they also help interpret that information. So they are very useful indeed. So in a nutshell, EPD, what it contains, it's based on real data, so it allows no forecasting. It can represent either one product and one factory. It can represent many products from one factory or similar products from many factories. So there are quite wide ranges here. They're most often valid for 5 years. And there are several kinds of EPDs that represent different scopes. So as we saw those different tables with the LCA modules and stages, these kind of EPDs may follow different scopes. So they can be cradle to gate, which means that they have only the A1 to A3 modules. But these kind of EPDs are not that common anymore. They can be cradle to grave, which means that they have the whole life cycle included, or they can be cradle to gate or cradle to grave with options. So the new EN standard mandates the use of this cradle to gate with options, preferably cradle to grave plus module D, but it does mandate you to declare certain other parts as well, in addition to only the product stage. Yeah, and they offer knowledge of the product's environmental performance as well. And it is worth noting that only similar products that are calculated with the same method can be compared. And when you are making building life cycle assessments, you need to make sure that the products are actually compared within the building context. So if you have a hospital and you have a single family house, you cannot really compare, for example, a floor surface between those two different buildings, but you need to always make sure that you are comparing within the same function. So here's an example of what the real EPD looks like. So this is a Saint-Gobain EPD for low carbon glass. It has the front page here, which tells us that it's made in accordance with ISO 14025, which is the international standard, and also EN 15804 plus A2. So this is, yeah, so it shows this one. It also gives us the EPD operator name. And then the date of issue as well. So this is also quite important, and it shows the validity, so you know how long it's valid for. On the second page, it gives you program information, different kinds of information on the category rules and the verification. And then it goes on describing the product. So there's a lot of information in EPD. So here I've just chosen this one page, which is the most useful usually. So this shows the environmental impacts for each life cycle stage and module within the chosen impact categories. So here, as this is made according to the EN 15804 plus A2, we have a lot of different indicators. So we have climate change divided into 4 different parts: ozone depletion, acidification, eutrophication, and so on. Usually, if you're looking at carbon assessments, you would be interested especially in this total number for climate change. So this is basically the global warming potential for different modules and different stages. So there's also other kind of data than EPDs. So EPD always describes like actual products. So it describes one product from one factory and so on, as I mentioned. But we have also generics that might be very useful, especially if you are making an assessment in an early stage. You might not know what kind of material or what kind of product you are using. And in this case, you should make no assumptions on the actual product because you don't know it yet. So in these cases, you might use generics. So if you don't know which product you are using, you might use these product category EPDs, or you can use generic information that complies with standards. So for example, in One Click LCA, we have One Click LCA generics that are combined from several kinds of data, and they are always localized to your project location. So they are as reliable basically as these kind of like product category EPDs. If you do know the product, however, you are in later stage, the first source of data to go to is always the product-specific EPD. But if you don't have it, you can use generic EPDs or technically originally similar product EPDs or generic data that complies with standards. It is not usually recommended to use anything else than EPDs or other standard aligned data. Then shortly about legislation and standards before we go into the demonstration. So LCA follows standards, so that has been already mentioned a couple of times, but just to make sure that you know that this is not just some pseudoscience and guessing, it actually has a lot of like details behind it. So we have the cornerstone standards, the ISO, so the international ones. We have 14040 and 14044. So these two documents describe the fundamentals of LCA, and these are used in all industries and in all professional contexts almost all the time. So these are very widely utilized. But then as we have a specific sector, we are using also specific standards. So based on the ISO ones, in Europe, we have the EN 15978 for construction projects. And there's also the international ones, the ISO 21929 and 21931. And then, as mentioned, for EPDs, we have different standards as well. So the cornerstone standard here is the ISO 14025, and then we have the European EN 15804. And then also the international ISO one that has been developed on the basis of the cornerstone ISO 14025. And all rating systems and methods approved either ISO or EM-based LCA or both. So as mentioned here, we have the basis, the 14040 standards and the construction standards, and here more detailed the European standards. And then we have the national regulations and the voluntary environmental certification schemes. So these are something that you might have heard before. We have, for example, BREEAM and LEED, which are the two most biggest voluntary certification schemes out there. And then we have different regulatory ones. So I'm based in Finland. Here we have our own system that is based on all of these. In France, for example, there's RE 2020, and in Europe, the general framework is called Levels. And this is something that we will be returning to as well. So the EN 15978 sets the rules for building LCA. As mentioned, all schemes and regulations follow the standard in Europe. There are some exceptions that may take place, especially in which life cycle stages and modules are assessed. So as I mentioned, the Finnish method, for example, it omits some of the use phase modules because they are difficult to assess. For example, B1 or B2 or B3 are omitted, but then all the major modules are included. There's the regulations that are ever tightening. So European Union has already existing regulations, and there's also some tightening planned and also published. So for example, taxonomy for sustainable activities, it requires LCA from certain kinds of projects. And there's the energy performance of buildings directive that was just updated and is now being implemented in member countries. That also includes whole life cycle assessment for buildings. So many countries have their own regulation related to building sustainability. And here I have the example of France. So your project is based in France. So you should be aware of the RE 2020 regulation. So if we take a closer look at RE 2020, the aims and objectives are to reduce impacts of new buildings throughout the life cycle, improve the energy efficiency, and adapt to a changing climate. And what in this regulation, there's a lot of information. There's a lot of requirements related to indoor climate and so on. But there's also life cycle assessment related parts. And there's two indicators. So indicator, carbon indicator for energy and carbon indicator for construction. So these are calculated with a whole life cycle assessment, and it's a mandatory task for most new buildings. So this means that buildings that are currently being designed or built will have to comply with the requirements of RE 2020. So this is uses a dynamic LCA approach, which is a bit different from the static one that is used in most places. So the dynamic LCA kind of like puts more weight into emissions happening now than what they do in the future. So it's the kind of like the decarbonization of certain things is taken into account here. Yeah, so impacts are larger now and will diminish in the future. The important part here is the carbon limit values for new buildings. So in order to get a construction permit, the impacts need to stay below the limit values. So if we take a closer look, there are two different limits. So one is the carbon indicator energy, and the other one is for construction. So basically the embodied carbon of the building. So you can see that the energy limits consider have a bit more different approach. So there's some oops, sorry. Yeah, so there's like different limit values for with different kind of assumptions. You can see here that they are tightened every 2 years. And here we have the construction part. So this applies to single-family houses, apartment buildings, offices, and also educational institutions. And it's expected that there's more buildings going to be affected in the future. I also attached the newest guidance here, so you can take a look at it yourself. And also in our materials in the Academy, you can find also a brand new course on RE 2020, which is unfortunately only in French at the moment, but you can take a look if you're interested to learn more. And in the context of this contest, so Levels is the tool that we're offering you, and it's suitable. You can use suitable data with this one. And for the contest, you should be able to go below the carbon caps of RE 2020. But now we've concluded our quick introduction to the world of LCA. What you need to know before you begin, what kind of data you can use, and what are the main standards regulating the process. So now we will continue with the software demo and begin with the basics. So how to create your account. Before we go there, I will tell you a little bit about our tools. So OneClick LCA is a software that combines several assessment tools. And with these assessment tools, you can align or comply with different kinds of regulations or these kind of certification schemes. So for example, we have a tool for BREEAM, we have a tool for LEED, we have a tool for RE 2020, but we are offering you Levels, which is the European framework for life cycle assessment or the sustainability of buildings. Here you can click and you can find more information in our help center. So feel free to go and check that out. This is a full cradle-to-cradle assessment tool, so you can assess the entire life cycle and more. We have added also the tool for Carbon Designer 3D. So this will be examined more deeply in Thursday. And we also have added this circularity tool that might help you if you are making, if you want to investigate more closely how your materials impact the actual like circular performance of the building. But then if we go to your account business, so how to register and how to activate your account. So what you would need to do is to go to oneclicklca.com, and there you have to log in from the upper right corner, and then it gives you this kind of like a pop-up that prompts you to give your details. So if you're a new user, just click register here, fill in your information, and then you will get an email, and you just need to be sure that the email actually reaches you. So one of the most common mistakes is to misspell your email. So check that. If you don't get an email, and your email address is right, check all the other folders. So usually they might tend to go to spam. If even after that you don't get the email, please do send email to me. Yeah, and then from that email you need to click activate, and then you are good to go. And then you can actually log into the OneClick LCA platform. So then once you have done this, you will need to create a building project. And here is where you can add your license key. So we offer you a license key that is actually written here. This will be also added into the Academy page in several places. So be sure to use that. I will show you how to activate it in a while. So don't pay attention to it yet. And then, yeah. And one thing that you should remember is that OneClick LCA is a cloud-based software, so you don't have to download anything. So what you need to do is go to oneclicklca.com, and then you can continue from there. And then once you have fed in the license key, started your project, it gives you all these different steps to fill in, but I will actually show them to you now, so we don't need into more detail here. So you can actually forget all about the registration for a moment. So if you haven't done this already, there is plenty of time for you to do it afterwards. So now that I go to the software demo, I hope that you will actually pay attention to the demonstration instead of trying to duplicate what I do in real time. So you can always return to the recording and then see how things are done. Yeah, so now I will actually, exit full screen. And we will go to OneClick LCA. So once you have registered, this is what it will look like. You will sign in. Just put this here. All right, and then what you will see is the main page. And I'll just zoom in a little bit to show you what it looks like. So this is your main page once you have created your account and registered and activated your account. You will be accessing this kind of view. Here you can see that you're in your home pages, your projects, and whatever projects you create will show below here. There's also a bunch of public demos that you might want to take a look at. So here you can't, of course, make any changes to these, but you can open them and see how they are created in case you are interested to know how these actually would work. Well, let's go to your projects, and then we will go to here. So there's a place written add, screen button here, and we have different ones for what kind of projects you can add, but these depend on the license. And for you, we only have the building enabled. So you can click on the building. And this is the important part. So we are now creating a new project. And here the first step is to link the project to a license. And since you don't have a license, you will enter the license key. And this is now. And it is case sensitive, so make sure that you write it correctly, and then you just activate the license. It says you found the license, and we are happy with that. And it shows in red the mandatory parts. So here we are creating the folder. Well, you can't really change it. I think it goes directly to main page. There is no need to change it either. But then you need to choose the type. So what kind of building you are making. And it also says that if the building has several types, choose the most suitable. So this doesn't really affect the actual calculation, but it is useful information, and it might like make some kind of assumptions related to it, for example, related to benchmarking. So let's start with apartment building. We have several different buildings here. So feel free to choose any type you want. For the new building, I remember it's a multiple use building with that it was also described to be partly at least an apartment building. So this might be a good place to start. Here, remember to choose the country. So the project is located in France. So this is what we should also choose because it uses this preset as a basis for localizing certain things, and also it provides you, it offers you the correct type of data. So it basically preferably offers you French data here. And then we click next. So this is optional information. If you know, you can fill in gross floor area, number of above ground floors, and also the frame type. But if you're not sure, you can leave this blank, and you can always define these later on. If you fill, for example, gross floor area now, it will populate some of the fields later on in the assessment tool. But you don't have to fill in anything now unless you want to and you have information. There are other types, so you can add images, for example, if there are certifications being pursued. And also, this is probably not relevant here, but project numbers and so on, but these are, as mentioned, only optional. So then we can click next. And this takes us to the project main page. So the first one was your user main page, and this is a project main page. So you can create how many projects you want. There is no limit, but within the project, you create designs. From here, the general information, you can see the date, who it was created by, what license it's tied to, and some other information as well. But when we begin, we need to click Get Started, and then it takes us to the available calculation tools. So as mentioned, we have added levels, life cycle assessment, and also the building circularity tool. And there are several options here, but this is because we are changing, updating the data. So actually this one that says new version available, I recommend you don't choose it. So what I would recommend you to choose is this levels EN 15804 plus A1, and also the EN 15804 plus A2. So this is, as mentioned, the related to the source data. So if the EPD is made according to the old standard, it's plus A1, and if it's made with the new standard, it's plus A2. But sometimes as the A2 is being implemented and A1 EPDs still exist in the market, it might be that you find materials more easily if you choose both of these. And for building circularity, you can choose the basic one or the beta version, which has some new features and is also being updated. But I will now choose both for demonstration's sake. And then we create the design. So let's create, for example, design 1. The name is actually the only mandatory part here. It gives you some options that are like pre-chosen. So here we can further choose the tools that we want to use in this design, but you can easily choose all of them. You can use the levels EU scope, but I think that it takes it into account automatically here. And you can also define what kind of project type it is. Is it a new construction or something else? But I understood that here it's the new construction, so you might choose it here. And also here you can choose the frame type if you want to, but it's not necessary. And here the included parts, so foundations, structure and enclosure, finishings, and so on. You can remove some of them, or you can choose all of them. I usually recommend to choose all of them, but you can always add these into the assessment also in later stages. And this stage of construction here, so you can also choose, it doesn't affect the calculation, but it helps to arrange the designs within the project. So if you have several different design stages, you might want to define them accordingly. But let's start with concept design here. So then we click next. All right, so the next pop-up is the parameters. So the parameters basically define some of the rules by which the assessments are made and the results are calculated. So you can use default LCA parameters if you don't know better. So this is an okay choice to make, especially with the levels tool, but I will show you how to review and adjust them in this case. And this is also something that you can do in later stages if you find out that you actually need to review some parameters again. You can change them, but they will recalculate all your results again for all the designs within the project. Here is also a good source for data. So if you need more information about the parameters, I urge you to check this out. So it explains this in a bit more depth. But just quickly, what these parameters do is they define how to calculate the replacements of the materials. So here we have the service life parameters, the transportation distances, material manufacturing, localization, and so on. So the service life, as mentioned, so this defines how the replacements are calculated during the assessment period. So the technical service life is the default, and this is a good place. So it's the same for same material. So whenever we have concrete, we expect it to have the same service life as concrete usually does. Or whenever it's, for example, a window, we expect it to be like the basic service life expected for windows. If we are making a commercial project, for example, we have a retail shop, or we have like an accommodation building, for example, we might actually use this commercial service life. So it's the same for same material, but it's shorter than the technical service life. So this, for example, a floor finish would wear more quickly in an accommodation building than it would in a residential building, for example. So this takes this into account. Then there's a product-specific service life. So this is a value that is taken from the EPD, but it is usually not recommended because the manufacturers have their service lives declared in ideal situations. So it might be, you know, it might be longer period than what it would be with the technical service life. If you're using certain kinds of regulatory databases, such as we in Finland would be using, or for example in Germany you would be using Ökopaudat, then you might be wanting to choose this one because it takes the data from also the mandatory database. And then in Great Britain, there's RICS default service life, and in Norway there's also a specific service life setting. But here I would recommend you to take the technical service life unless you are making a commercial project. And then how to define the transport. So if you are further on in your design, you would probably know where the materials come from. So you would know the transportation distance. But if we are making these kind of designs in more earlier stage, we don't yet know where the material is actually coming from. We might be using these generic data points and making these kind of a bit more vague assessments. And in this case, it's important to set the transport distance accordingly. So if we are in Europe, we would be using the European transportation distance. So this is basically the average transportation distance for a certain kind of material. And it's a good basis. So whenever you have more information, you can later on edit it. But this is something that is a good place to start. And you should always have some kind of transportation distance in your assessment. Then there's the material manufacturing localization method. So here we have different options. You can disable it. It's always used for the generic data. And there's different kinds of versions. And here it says recommended. So go for the recommended. So this is basically something that adjusts the material manufacturing process emissions for the grid electricity and energy efficiency of the project location. So if we are in France, but we are using a material that comes from, for example, Great Britain, or we are using a generic material that is, localized for France, it would actually take that material and replace some of the impacts that derive from the material manufacturing into the specific grid of France. And in this way, we would have like a material that is a good proxy for something that is actually made in France as well. And this does not affect any materials that are manufactured in the same country. So, but anyway, here it's recommended to use this version 2.1. There's also the target, but if you chose the correct project location, it gives you an assumption here. So this is basically what kind of energy grid you would be representing here. So this is a good one here. And then we have the end of life calculation method. Again, we have different options here. So there's material locked, market scenarios, and EPD end of life scenarios. You can see here that these are both user adjustable, so you can edit them if you need to. And here recommended is the market scenario. So this is something that for a certain material, it takes the end of life scenario of what is expected to happen to it. So if you have wood, for example, is it incinerated, used as energy, or is it landfilled, or is it recycled? So this is like takes the predominant market approach for that certain kind of material and gives it as an end of life scenario. Again, the EPD end of life scenario is usually not recommended, again, because of the reason that the manufacturers might actually optimize these, so they might be a bit more optimistic in their approach than what the actual situation would be. And then there's also this country-specific site wastage, but it's not applicable here. So this is only for United Kingdom and Norway. So you can choose global. Okay, but that was it about the parameters. And do check this out if you're more interested. For example, the localization might be a bit difficult to understand, but there's a very good explanation here in the help center. So just go and check the article out. And then remember to save. Yep. And then we have now our tools here, and we have adjusted our parameters here. There are different options now where we can continue. So this is our design. And when we calculate, we get results here. So first off, you need to choose a tool. So you can use either this plus A1, but it doesn't contain this plus A2 data, or you can choose plus A2, which usually doesn't contain this plus A1 data. So I would probably recommend to go for the plus A2. And in case you find that there's not materials that you want to be using, then you might want to check out if you can find them through this other tool here. But let's start with the assumption that we are using this plus A2 levels. So you can go here and click this little arrow, and it shows you this kind of table, or this kind of like a well, what do you call it? The table, yeah. Here you can see with red whatever is missing. So basically we are missing everything because we don't have any materials or anything there yet. You can go to different sections from here. You can also view results once you have the results, and you can also import data. So we are not covering import in this session, but you can find also very good information about it in the help center if you're interested. So this allows you to bring all the data at once instead of putting it in manually as we are doing now. So let's start with the building materials. And it prompts you to use the beta interface. You can do that if you want, but it's still lacking some features. So I would say no until it's actually finished. And then it takes you to the actual tool. So here we are within the building materials query. So on the top here, you can see all these different tabs. So as we did in the previous page, we also saw that there are different sections. So here you can also move between these different sections. So this is something that will allow you to put like basically all the data that you need for your assessment. So you have the building materials, you have the energy consumption, water consumption, the construction site activities, emissions and removals, maintenance, and then also the calculation period and the building area. On top, we have filters, and we are going to check those out in a moment. But first, we can see a bit closely on the building material query. So this is divided into sections. So we have here one, which is foundations and substructure. Then there's vertical structures and facade, horizontal structures, other structures such as windows and floors and finishes, and external areas, and also building technology. So this is something that makes basically your life a bit more easier. So the materials are separated into these sections and they are more easy to handle. So basically, instead of having everything in one, it's easier to navigate when they are separated like this. And then what you will start doing is you will start adding materials. So if we check first this foundation, for example, so basically all these drop-down menus open the whole database, and you can see that there's a lot of data here. So we have thousands of matches for different material types, so there's like these MEP components, different insulations, everything that you basically need, all the materials. But finding a material here is very difficult. So what you can do also is you can start typing. So we want to add some concrete. And again, basically it gives you all the concrete matches that we have. So we have ready mix, wall elements, masonry units, admixtures, everything. So it's easier maybe to narrow it down a bit. So you might add some type of material. So for example, concrete, C2025. And then you again get a more narrowed search result. So let's add some concrete from here to our foundation. So once we get the material type that we want to, it opens this kind of menu. And here it gives us local generic data. So you can see here we have the French EPD system, we have OneClick LCA generics, and so on. It gives us regional manufacturer-specific data. It gives us other manufacturer-specific data, and so on. So there's a lot of data that you can choose from. And as mentioned in the beginning, it's the most recommended one is to go for the generics. So don't go for EPDs at this point yet, unless you know exactly what you are going to be using. And here we have the different carbon clouds. So these make it a bit more easier to compare. So for example, here we have all the different ready-mix concrete, normal strength, and they have different amounts of recycled binders. So you could think that maybe we can start with this 0% if we don't know, or we could start from this kind of typical mixture that has 10% recycled binders and it has a slightly better environmental performance, and so on. So you can make a lot of choices here. So let's choose this typical one, and then we can add a quantity. So for example, 1,000 cubic meters. And here we have the units. So if we decide that we are actually making a slab, we can also change it into square meters. So this gives us an assumption of what the thickness is. If you change the thickness, you will need to also recalculate this quantity. With every data point, there is a data card. So this green question mark here. So if you click it, it will open the background information for you. So you will find general information, the background information, what was the EPD program when it was made, what kind of PCR does it align to, and also descriptions on how the data point is created, and also these kind of technical characteristics such as mass per unit and so on. And here you can also find the environmental profile. So you have the actual global warming potential of the material per unit. And here you can also see the performance ranking. So, so when you start making the optimization of your designs, you might want to pay this a bit more attention. So you can see the actual environmental performance of this particular material in comparison to others. Okay, and then when we have added a material, you can add comments. So when there's a lot of you working with the same design, so if there's a group of you, please write these comments, because whenever one person makes changes, it's difficult for you to keep track. So this is something that you should pay attention to, so that you are all in line with the changes that have been made. You can assign the building part. So this is important in when you go to the results. You have your emissions and impacts divided per building part. So this is something that you should check that it's correct. Company classification is not here something that we need to pay mind to. And here is the transport. So we use the average transport distances for European projects. So it gives us 60 kilometers with a concrete mixer truck. You can change it. So you can edit it. It might be 50 kilometers. And you can also change the type of transportation that you are using. So there's quite a lot of data points again here. Let's take, for example, is there a French private petrol car? Well, probably won't take that one. But anyway, you can choose whatever transport type you want here. If you have 2 legs, so this means that you are doing the first transport section with a certain kind of vehicle, and then you can add a second leg if you are making this with another kind of vehicle, for example, something else. I don't know. Something, for example, with a different kind of fill rate or whatever. So this is something that you can pay mind to. The service life is given here. So for foundation materials, it's always permanent. So it can't be edited, but for other kinds of materials, you can always edit it. So it gives you the default that comes from the parameters. So it's a technical service life in this case. And if it gives you a number, then you can also alter it. Here it gives us the localization. You can see that we're in France. you can set the repair. So of course for foundations we have no repairs, but if it was something else, for example a wooden cladding, you might want to put a percentage share of repair that takes place every year. It's not something that's mandatory, but you can add it in if you wish. There's the wastage. So this is something that's always tied to a certain kind of material, and it's also editable. So if you know that there's more waste being produced, then you can edit it here. And you can also change the end of life process. So this was also from the parameters. So we chose the market scenario, and this is the market scenario in France. So it's concrete crushed to aggregate. You can also do nothing, which means that you would leave it there, or you can also choose landfilling for this kind of material. This is something that's important to note. So if you are adding in materials that are reused, so they have been in some other use before, and you are using them again in this project, you might want to click this. So this means that the product phase emissions are omitted, so they are not calculated again because they are already being calculated in the previous lifetime of this material. If it's something that has been there on that site before, so for example for foundations, we could see that we are building on the foundations of a previous building, and then it would also leave out not just the product phase but also the transport and the installation and the construction site activities related to that. So that is something that you might want to check. All right, so like I showed you, we have a lot of data here, so there are thousands of data points, and then this is where also the filters might come in handy. So you can set certain kinds of like boundaries for your search, so you can search for certain kinds of materials. So for example, we want to find, for example, insulation. So here you can choose different kinds of things. For example, we want to choose glass wool insulation, and we want it to be specifically French. You can choose the data source here. So you can choose the EPD program, or you can look, for example, only these One Click LCA generics, for example. Or you could choose, I saw that there was also like a European, no, global average as well. You can choose the type, so it can be generic. So is it something that, that is an average, for example? Is it manufacturer specific, or is it specific to a certain type of plant, for example? So you can choose these here. The upstream choice, it's basically where the upstream processes originate from. So are they usually there from EcoInvent or Gabi or both? This is not usually something that you need to worry about when you're making building assessments. It's basically when you're modeling materials, then you might need to pay attention to that one. But you can also choose here the carbon intensity. So as we saw, we have those carbon clouds. We can be very low, very high, or something in between. And I want it to be average in this case. You can search even for certain kinds of materials or what standard it aligns to. So we have now chosen certain types of boundaries here. And this might be useful if you're looking for certain kinds of materials and don't want to, scroll the whole thing up and down and search from there. But now when we click this external walls and facades, for example, we get only glass wool from France with a certain kind of environmental performance. So for example, here I would choose to use something like Isover, for example. And we can add, for example, 100 square meters of this one. Yep, so that was it about. I'll just check my notes where I am. Okay, and then what we also have here is constructions. So this is also something that might be useful in early stage when you don't know the exact composition for example, for a wall. So we can also choose a construction from our filters. So we want to add an external wall. And let's go and check. So it gives us only constructions, and I will show you what it looks like in a moment. So we want to add, for example, a brick sandwich wall. So these constructions are something that are made by OneClick LCA. They are based on several types of data. So there's a lot of different research and a lot of data and industry knowledge like behind them. So what we have here is a typical brick sandwich wall within the EU. So it gives us all the different layers that we need, all the materials that are needed to create this kind of wall. And when we put in a certain amount, for example, 1 square meter, you can see that it populates all these different material rows. So for 1 square meter, you would need 112 kilos of bricks and so on. So this is very useful when you don't know exactly what these kind of wall elements or floor elements or roofs or something like this, what they would be composed of. And then once we have, remember to hit save every now and then, otherwise you might lose something, and there is no undo button also here, so that is something that you might want to remember. If we look at these constructions a bit closer, so we see that, you know, we have these bricks and mortar and stone wool, and we realize that we actually want to, you know, use this one, but we want this to be glass wool. Then we can go here at the end. We have this change button. So if we click here, we have different options. So what we need to do with the construction is we can unbundle it. And this leaves us with only individual rows. So now we cannot modify these simultaneously, but they are now individual data rows. So what we can do is we can save. And then we can do different things. So once we have saved, we can actually choose the stone wool, and we want to change it into something else. So it's this one. This change function has different things in it. So we use this unbundle function first, but we can also use replace. Let's see what replace gives us. So it gives us the original material, and then we want to change it into this glass wool. Let's see, so where does it work like this? And then here we can find the material that we were using before. I think this one is maybe the same one. So it opens the data card, and then we can save, and we don't have to basically type any numbers again. We can just use this to replace, and it will get rid of the old mineral wool there. So now we have our materials, and it has replaced the mineral wool with glass wool. And now we want to actually start editing this again as a group again. So what we can do is we can left click and drag paint over them, and oops, so that they turn green. And click here with right mouse button, and then we can create a group. And the group name is new brick wall. Oops. And the reference quantity is the most important one. So for us, it was 1 square meter. You can assign it a type for it. So this one is actually an external wall construction. You can create a description. You can assign the building part if it's not assigned already. So here it assigned it already. And you can also create the group for either, well, you can only create it for this project. I have a company account, so I can also save it for everybody in my company to use. But I think that here you need to choose only this project. And then once you save it, we have the new construction here with your materials. And then again, when we change the amount, we can see that it populates all of these different ones. You can also create a group by using this function here. So you just click the create a group, and it opens up the same kind of pop-up as the previous one. And here you can also assign the group name, the reference quantity, and then you can just drag and drop these materials there to create your group. Now, yeah, so that's it. And one thing you can also do, so for here, for example, we had the concrete. You can go to change, and there's also a function called split. And I know that I want to add some like rebar, reinforcement steel into my foundation. Oh, oops. Yeah, the filters might sometimes offer you something that you don't want to. So check if something is not working, you might want to check the filters. Let's see if we have reinforcement for concrete. I have very weird results here. For some reason, it doesn't give me all the data. But as a sake of demonstration, we can choose reinforcement, and then we can add, I don't know, 3% of reinforcement there. And it totals into 100. So we have now noticed 97% of concrete, and then we have 3% reinforcement steel there. And then we can save. So if you have numbers, of course you can feed them in, but if you don't, you only have percentages, then you can use this function to actually include them. Right. Then let's take a look at the other fields quickly. So this was the building materials tab. Also here, just as a reminder, the building technology, for example, if you're adding photovoltaics or some kind of like, well, anything basically related to the technical components, you might want to add them here. External areas are not necessary, but you can include them if you want to. And yeah, that's about it for this one. So let's go to energy consumption. So here we have tabs for, or sections for electricity, fuel use. So if you have fossil fuels or biofuels that are used in the building, then you might want to add them here. If you are consuming district heat, you might want to add them here. And if you are creating energy, so you have, for example, the photovoltaic system on the roof of the building, and you're exporting energy per year, certain amount, you can add it here. The electricity use is the only mandatory part here. So we can, for example, add certain kind of electricity. So I can see here we don't have, let's take, for example, this one. So this is a very generic data point for electricity used in France, and we are using, for example, 10,000 kilowatt hours. In early stages, you might not know this already, so you can always just fill in 0, but you have to put something in here for this to work. So you can put either 0, 1, or an actual number if you know. The program saves automatically when you're jumping between these tabs. So there's, in this case, no need to save, but when you're inputting materials, remember to save every now and then, otherwise your data might get lost. The levels tool includes water consumption. So this was the B7, operational water consumption. Here you can add an annual number if you have it. If you don't, then you might want to leave this blank, so you don't have to fill in anything here. If he has this kind of like a check sign, then you know that you need to put in something there, or this kind of like a red arrow. Then we have the construction site activities. So this is the A5 module. So when you are making an actual LCA, you might have information on the energy use on the site. So it depends on the stage of your project, of course, but you might have information on the site, electricity consumption, on heating, and so on. And the materials used on the site that do not constitute part of the asset, water use, and additional trips. But the thing is here that when you're making this early stage assessment, you would use a scenario. So this is something that is an average impact for a construction site in this area. So we would be here using a scenario for, we have European averages, global averages, and it seems that we don't have one for France, I think, but we can use average site impacts for, I think, temperate climate south. And this is biodiesel as primary fuel, so you might want to check this out with so which one might be the most useful in this case. And here you would put in the gross floor area of your building. And also the deconstruction and demolition, if you want to, you can use a scenario to estimate. For example, if we have a concrete frame building, let's assume that we do, we can also add the gross floor area, so it calculates the impacts based on that. Then we have the emissions and removals. Yes. So here the thing is with these refrigerants. So this is the module B1. So it would include, if you have, I think in the plus A1 tool, you can also add vegetation. So if you have vegetation, you can add certain amount of carbon removal during the lifetime of the building. But here we only have refrigerants. So what you can choose here is the type of refrigerant used. So for example, these different European averages, and also if it's banned in EU, don't choose it. That's not a good thing then. For example, we have this one, and we have, I don't know, 1,000 kilos of this one, and then we have an annual leakage rate. This can be adjusted, but it is also tied to these certain kinds of assumptions on the material, on the equipment, and what is the actual average leakage rate of different refrigerants within the EU, and also the end of life leakage rate. So this is, if you know better, you might want to choose to alter these. If you don't, then you might want to leave them as they are. We have also maintenance. So this is module B2. It's not an, well, it is a mandatory one, but it's basically it gives us a default of not having anything in it. So this is, you can use scenarios to put here, what kind of maintenance is expected, and also these kind of values that you might fill in if you have more information. But as you saw, it was a green check from the beginning, so that means that you don't really have to change it if you don't know. Then the calculation period. So levels, as all the schemes in Europe, uses 50 years. So you need to fill that in. And then the building area, unless you have filled this in the earlier stage when you are creating the project. So let's see. The building area, it gives us what is required. So here we need to add the gross internal floor area, so that's the GIFA. So that would be something like 2,900. You can add more. You can add this number of users, or you can use these gross floor areas if you want, but this is something that is required by the tool. So you need to add the gross internal floor area. And once you have these filled in, you can then jump to the results and check them out. And we will actually go through the result page in Thursday's session. So now, because time is going a bit fast, I will just quickly show that it gives you a very detailed results for your assessment. So whatever you have filled in shows then here. But let's check this out a bit more closely on Thursday. So from the results, you can always go back to the different tabs, or you can jump back into the actual project main page. So now that we have added in data, it gives us also results here. And what we can also check are the graphs, but we will also look those a bit closely on Thursday's session. Quickly, I will show you the circularity tool. So let's check the old one. So it looks very similar. It gives us all the different sections. It gives us all the materials we have fed in. But it gives us also these new things. So you can add percentages for recycled, if it's renewable, if it's reused, if it's designed for disassembly or designed for adaptability. And you can also, again, change these end-of-life processes and also mark if it's a hazardous material. So for example, here, it gives us for our construction, you might want to check these out if it's like highlighted in red. So with the constructions, you need to alter these. You need to open it and alter these within the construction. So let's say that our walls, for example, are designed for disassembly. So we can click this, and then we can see what the results look like. The calculation here is based on the circularity score weighing factors. So when we jump from the material query to the weighing factors, we can see that virgin materials, for example, get a 0, so they are not weighted with anything. The renewable, recycled, and reused have a weighing factor of 1. And if you have materials returned at end of life, you get also different kinds of factors here. So if it's reused as material, it's a 1. If it's downcycled, it's 0.5, and it's disposed, it's 0 then. And then we can check out the results. So what it gives you is basically the circularity score of your project. So for us, of course, we didn't have basically any materials there, but with the we had reused foundations, for example, and we had walls that were designed for disassembly. We already get like more a bigger building circularity result than what we would without those kind of choices. And then it also gives us a bit more closer look into the recovered, returned materials, and also different kinds of results for the key material groups. So this might be useful if you're interested in the circularity of your designs. Okay, but now that was it for our short demo. And I will just, go back to the presentation quickly. Yes, so that was the quick demo. And in case you're interested, we have some self-study materials attached here. So you can check out the emissions gap report and also the embodied carbon review that's published by OneClick LCA. And I would urge you all to familiarize yourself with the OneClick LCA software. Then again, I would remind you to check out the community page at the OneClick LCA community. So if you have any questions, please just write them there, and we will try to answer them for you. and make this thing a bit more like fluent for everybody, and also connect with your fellow students and also check the announcements. And now, if we have any questions left, there's 10 minutes time. So if you have something, you can write them in the Q&A and we can try to answer them. So I can see here, do we have any? What methodology was used to calculate the circularity score? So this is actually based on a British methodology. So I can't remember exactly, but there's this GLA methodology in the Great Britain that is used in the Greater London area, and in that scheme there is also this circularity that is very, very important, and that is something that I think has been used here as well as basis to calculate and to determine the scores and the weighing scores and to reach the results. So it's based on that, but it's also based on other things. So we have also a Help Center article on the matter explaining the whole process. So just to show you the Help Center. So this is what it looks like, and you can find a lot of information here. So for example, the circularity tool. So you can find a lot of information about this. So it's written here that this can be used for different kinds of schemes. And I think that it explains here as well a bit more about the background, and then tells you what to put in the building query and how these are filled in, and also about the design for disassembly and design for adaptability. So yeah, check that out in case you are interested. Yeah. Is there anything else anyone wants to know? I'm just thinking what else I could tell you. So do make sure to check out the Academy content. So I will add the recording there tomorrow, since it's evening my time, but tomorrow you will be able to find it there, and you can also find the license key to access the software. So you can find it on the accessing the software lesson, and also if you access these slides and recordings, you will find it there as well. Will it be possible to calculate the circularity score according to the levels 2.4 indicator in the future? Good question. I think the levels is becoming more and more important because of the ever progressing regulations. So, for example, several European countries will probably be turning to levels as a method to do their whole life cycle assessments that are required for example, the EPPD. So I would assume that we are in the progress of, bringing more versatility to our tools, and at the moment the circularity tool version 2, that is still a beta version. It's already including things like the taxonomy and things like that. So I would assume that if it's possible to include, we would also take these kinds of matters into consideration and add them there if it's possible. So yeah, probably. That's the short answer. So if there are no more questions, I would then call it a wrap. And thank you all for participating. Thanks to Timo for his presentation at the beginning. And thanks to everyone listening. So I wish you luck with your assessments. And please, once you have the license key, go to oneclicklca.com and start getting to know the software. So and you will be then on your way to making successful building assessments. So thank you, and hope to see you on Thursday. So for the next session. So thank you, and I will now close the webinar.